Cool, ready to go. Good morning, everyone. Thank you for joining me this morning. I hope you're having a good NDC so far. My name is Phil Nash. I am a developer evangelist at a company called Twilio. Before I carry on, can I ask, who here has heard of Twilio at all before? All right, a few people. Cool. I was talking to you yesterday. Cool. If you don't know Twilio, we are a communications platform. That means we are a bunch of APIs that you can use to do everything from send a text message to build an entire contact center, send emails, and even faxes. We have APIs for all of those things. And if you are interested in learning more about that, we are sponsoring here, so do come up and find us in the sponsor area. We've got some little bits to give away, stickers and stuff. Come and have a chat. I'd also love to hear if you've built anything cool with Twilio as well. Tell me about that, because I love hearing that. Even if you don't think it's cool, come and tell me. But I'm not here to talk about Twilio. I am here to talk about Project Fugu. A bit of a bizarre title, perhaps. You might even be thinking, what even is Project Fugu? Or hopefully you read the talk description and that's why you're actually sitting here. Because Project Fugu is a project from the Google team, from the Chrome team, in fact, to push the web forwards even further. We have a whole bunch of APIs available to us inside browsers and for the web, but we are missing out on some that bring us the kind of parity that the native platforms have had almost since their inception. We've seen a bunch of advances in this more recently, and I've been very excited about service workers leading to progressive web apps, allowing us to sort of install our web applications onto people's devices, and that's very exciting. But we are still left lacking in some places, and this is the current project from the Chrome team to kind of push this forward and find out what's going on and give us more as web developers to play with. So a lot of what I'm doing today is inside of Chrome Canary, because this is all very new stuff, and actually we'll get into a bit more of that in the future. But if you are interested in this kind of stuff and you don't have something like Firefox Nightly, Chrome Canary installed on your machine, and if you don't like and if you like random crashes, and let's hope that this is Canary right here, so let's hope it doesn't crash during the presentation. It's probably updated itself overnight. Then you'll enjoy yourself. You should get hold of one of these. This is, I really like the name Project Fugu, because it evokes to me exactly kind of the problem with bringing these new things to the web. As we start adding features and functionality to browsers, arguably the most used application on anybody's device, we risk putting users of those applications at risk. Fugu, the pufferfish, is it's a delicacy in Japan, and you have to train for, I believe it's at least 3 years before you're even allowed to serve it, because do it wrong and you will poison and kill your diner. And that is the same for the web. If we get this wrong and we push out an update to everybody's browser, and it's wrong and it leaks information, it is less private, less secure, then we risk putting those users at risk and in danger. And we've seen this with native applications, and we'll see some of that. It's going to sleep. Cool. We'll see some of that a bit later. So let's carry on. It is all about privacy and security. That is the function of the web. Since the very beginning of the web, anything that we've had to do with difficult APIs like this requires permission. It requires you to say, yes, I will opt into that. Things like geolocation or push notifications, stuff like that. And I know you're probably annoyed by every website that asks you for permission for push notifications these days. And so am I, because that is something that we could have done better. But it's still, the permission is there. You don't just visit a website one time and the next day receive a push notification from them without expecting it. And so that permission is there to protect us as users and not to annoy us as developers. So how have we gone about building these new features for the web, or how browsers in the past have gone about building new features for the web and testing them with vendor prefixes? I'm sure you kind of recognize something like this, where request animation frame, very useful API, but we don't just get the window one, we needed to also ask for the Mozilla one, and also possibly the WebKit one, and maybe if you're thinking about it, the Opera one, and then just in case they implemented it, the Internet Explorer one. And that is a poor development experience. And the problem is, we end up leaving this code in our production applications because it worked for us. That got to the point where Firefox around version 46 started implementing WebKit prefixes for CSS properties that people had used. Things like border radius, where we'd done WebKit border radius the entire time, and then and never the standards border radius. So things still looked broken in Firefox, even though it was fixed and working in Safari or Chrome. And so they started implementing WebKit things. And this is wrong. This is not how we should do things. We should not be using these experimental technologies like this in production and leaving it that way. So that brings us to how should we be dealing with this? And you probably do this in your own applications by using feature flags, turning things on for certain sections of your users, or just for developers, or just in certain environments. Feature flags are a brilliant way to ship code that doesn't affect people and won't break the rest of the application. And so browsers, inside Chrome, this is the flag you want to look for those exciting new web features, the Enable Experimental Web Platform features. It looks a bit like this, with a warning, of course, as well. Experimental features ahead. By enabling them, things could go wrong, right? And that's fine. It's experimental. We know we're opting into this as developers because we want to try these things as they are new and as they land in browsers to test with. This is also why we're at risk of crashing some of the time as well. But that's fine. We know we opted in for it. I also have on developer tools experiments, which is also an interesting place to look into. We're not going to touch any of those today. And so cool. We enable a flag. We can play with the new stuff. That's great, right? But that doesn't really help us test with real users. We can't email all our users and say we implemented a cool new API. What we're going to need you to do is to go to chrome://flags, look for experiment, ignore the warnings, look for experimental. We can't do that for users. It's not emoji party time yet. So this is where we get to origin trials. This is the way that Chrome has decided to go ahead with this. As a developer and as a website, an application, you can opt in, you can request to join an origin trial. As I was writing this, this sounded to me like it was a Hunger Games style thing. It sounded very young adult dystopian future. One developer, one browser. Pick your browser, take it into battle, and it was almost like Pokemon as well. You're like, Firefox, I choose you. I don't. It's the most dangerous sounding browser when you think about it. These origin trials allow you to opt in as a developer that your application will be able to use an experimental feature in production. You can go to developers.chrome.com/origin trials, and that will actually. What if we did that? What if the internet's working? That actually shows you all the kind of active trials, and we're going to see some of these in action right now. Cool, the internet's been slow. That's exciting. But there's a bunch of them, and you just click that register button, and you are in. There's no kind of testing against this. But there are some... and so what you get back from that is a key, a long, unique key. And to opt that site into the origin trial, you then need either a meta tag or an HTTP header that you serve to the browser that includes that token. This is a token I used, or this is part of a token I used on my own site to test the web share API, which I'm going to show in a bit. And as you can see also here, it has an expiry date. And these origin trials have some limits to them. They're a fixed time limit. You know when it's going to finish. The origin trial actually ends early if usage grows to more than 0.5% of Chrome page loads. This is the Chrome team's kind of deprecation level. If things are less than 0.5% of usage, that's the kind of time we can start to remove it. But if an experimental feature gains more than 0.5% of usage, then we're going to stop it. Like maybe it's been a success, but we can't let it go on as a trial. And then ultimately the feature may or may not ship. Or it might ship in a different way, like the trial might come out with the fact that it was not built correctly and we need to try again. So this is origin trials, and if you want to start testing with your users, this is what you have to go through for it. This also is a good thing, is a good way to encourage us as developers to build these things as progressive enhancements. Now, these things are only going to work in Chrome. They're only going to work if the API itself exists and if the origin trial is still running. So you've got to be kind of really testing for the existence of and the working of the objects that you're about to use. So cool, that's the boring stuff out of the way, the kind of administrative things for exciting new web features. As I said, for us, for developers, just turn the flags on, we've got them. But if you want to take this to users, we need to get on the origin trials and get ourselves set up. So let's get on and see some of these APIs in action. What are we going to see today as part of this talk? Well, I mentioned it in that origin trial earlier, and this is a bit of an older API nowadays, but the web share API still excites me, and I wanted to talk about it anyway, and we have a little bit extra to share on that. There's the wait clock API, a contact picker, the native file system, and shape detection. Some of that doesn't even make sense, but we'll see what it means when we get to it. We'll start with the web share API. If you noticed on my origin trial meta tag there, the origin trial for it actually ended in 2017. And that was a good thing because it got implemented. And the web share API is intended to try and kill this guy. Like, not to stop people liking things, but to stop you having to include all sorts of third-party JavaScript on a page in order to make a like happen. Now, I'm not. This is kind of about social and sharing buttons and things like that. It is the web share API, and I have no opinions about whether you should add social sharing buttons to your site. Some people have opinions about that. Some people write about those opinions. I wouldn't take those opinions either. This is up to you, your own testing. Because when the UK government writes a blog post about how nobody was sharing anything and the social sharing buttons on their site, nobody pointed out to them that they're the UK government and nobody wants to share things using the social share buttons on your site. That's fairly obvious. So do your own testing on this kind of thing. I also recommend if you do your own testing and decide to include those buttons or to delete them, don't write about it either, because that looks bad when you then move your blog platform and your blog post about not including share buttons has all of these share buttons on it. That was a bad mistake. It was a bit of a mistake by the Signal versus Noise blog. That's the blog behind Basecamp, the team behind Basecamp. Bad idea. But this is about user experience, really. This is what the web share API is going to give us, and it's what's going to improve upon what we already had. You see, I did a little bit of a test and just took a web page and then added a Facebook and a Twitter button to it just to see what would happen. Just like and tweet. That's all I added. There's plenty others you can put on there, right? And just doing those two added 12 extra requests to my page from 5 new origins, 5 other domains. Didn't actually make the page any slower. That's fine. Not to start with, anyway. It did load another 1/4 meg of data, which turns out to be almost a meg uncompressed. Thank you to buttons. There were some on-page performance interesting things. This is my website without share buttons on it. It does one thing. That red bit there is where the page is inactive. Oh, yes, when it's red on that line, the page has gone inactive. You can't click on something. Because, as you can see, the top part is the browser's main thread doing some stuff. And, right about there in the middle, right about here is clearly where I ran some JavaScript and locked up the page. But for a very short amount of time. It's pretty, that's a good amount of green there. But adding those 2 buttons for sharing and liking did all of that. I'm very disappointed that 2 bits of JavaScript that I didn't write are going to add all that red to my page by page interactivity, because that is directly affecting any user who is trying to interact with the page at the time. And this is a site that doesn't have a lot of JavaScript on it in the first place. So if you already are doing a bunch of other stuff, if you have a framework involved and you're rendering things and re-rendering and diffing and all that kind of stuff, you've got stuff to do already. So having share buttons lock it up is a terrible thing. And then there's privacy. How many cookies do you think the Facebook like button drops on your users when you put it on your site? Any guesses? It's 30 in total. between Facebook and Twitter. Twitter need 20 cookies, apparently, to know that you had a tweet button on the page and you visited that button. It's concerning. It's concerning. And there was a case earlier this year in Europe where a court sided against a website and Facebook to say that... So in Europe with GDPR, which you've probably heard a lot of, in fact, we've gone a bit quieter on it now because we all implemented it and we're all fine. But with GDPR, you are responsible for both the the transport of data and storage of data, if that's what you're dealing with it. And the European court ruled that sites that include a Facebook button or any kind of Facebook script on it are just as responsible for the transport of that data to Facebook as Facebook is for the transport as well. You're not responsible for storing that data. That's what Facebook does with it is up to them. But you are still responsible for getting it to them. So, dangerous. Do you trust Facebook to look after everybody's data like that? Who knows? Both of the things start sending beacons for events all the time as well, by the way. They're tracking your user on your page. Which is interesting. Did they read the article? Did they do the thing? What have they been up to? So including those things is weird. And then when I added the two buttons to that page, I didn't try and add them in any particular way, but this is what they came out looking like in the first place, which annoyed me. Because I like writing CSS, but only enough CSS. I don't want to write more to deal with somebody else's mistakes. So the solutions. Initially, the kind of Twitter and Facebook have a URL which you can just send a user to. That's fine. It's not as good a user experience as the button, but we can do this. The problem is everybody has one of those URLs. There's a great site, sharingbuttons.io, which allows you to generate buttons for all sorts of places you can share to using their kind of sharer links like that. And this is a good site. It gives you tiny SVG logos for the things and nicely formatted buttons, but it gives you a lot of them. And there's, the question is always which of my users going to share with? Which ones do I include? Facebook, do I add Facebook, Twitter, Google+, not anymore, Tumblr, Pinterest, email, LinkedIn, Reddit, Zing, WhatsApp. Zing is a German business site. It's the German LinkedIn. Which one do you use? You don't know what your users want to share to. You don't know what applications they've got installed. You don't know where in the world they are. You might know where in the world they are. And that's where the web share API came in. So it's a really simple API. It's so good. Navigator.share. And you give it an option of stuff, a title, a URL, a text. And that will then pop open the... it is a promise. If the user manages to share something successfully, then it will resolve successfully. If they do not, if they decide not to share, if something goes wrong in the sharing, you will get a failure. But what's nice about this is also you don't know where it got shared to. The browser is not going to leak back that data to you about where the share went to or why it failed, which is cool. We don't need to know that. We'd like to know if it worked, I guess. But what it does is, there's two things. It needs HTTPS, all of these cool new browser things, and in fact, everything else I talk about for the rest of the day is also going to require HTTPS, a secure connection, in order to use it, and it will just straight fail if we don't have it. But hopefully you're all moving to HTTPS or have done so in the past. And it also requires user input. It needs somebody to press a button in order to trigger this. You can't just arrive on a page and the share overlay just instantly appear. Unlike permissions for push notifications or any permissions at all, which are annoying. I wanted to show a demo, and I wanted to show, I have an Android device here. Apologies if we get ads on this. I tried to buy this software earlier today and I couldn't, which was annoying. This is my website. I thought I'd choose it to demonstrate this. I just have a link at the bottom there that says, if you like the post, please share it. And if you click share it, boom, a little share thing. And also apparently people who are in the audience or in the room. So we can share via Twitter, for example, and that will go and open that and start sharing. Cool. I think that's useful. Delete that. I won't share that right now. But what I really like about this is over here is iOS. They implemented it too. Woo! Well done, Safari. We got something done, which is cool. And again, Twitter has disappeared. I don't actually use this that much apparently, but anyway, and dismissing it like that and not sharing, that's causing a rejection in that promise, as you saw before. We did see that, but yeah. Cool, so it's working in Safari. That's somewhat bizarrely enough, it works in desktop Safari as well, because they went whole hog on implementing it, and that's cool, it's good of them, but the share options on desktop Mac are not particularly good. You only have Twitter and Facebook there, so you might want to look into, if you decide to use this, whether which browser you're actually on, or if you're on desktop or mobile, as it might not be worth it. This is what the sort of can I use looks like. It's a sea of red, of course, but that's not the worst thing in the world, because that sea of red is pretty much all mobile browsers and Safari on desktop. Adding up for this morning's global count of 47.3% of the world can use this API, so worth implementing probably. But it does pose a problem, which is we're building web applications and we want them to be more appy and act like this. But when we then pop that share API up, we're popping up the native thing, which has installed applications on it. So we're kind of getting out of the web and going back to the native applications in order to actually do the sharing. So that brings us to the Web Share Target API. And this is the newer, more exciting thing for us. Web Share Target API allows a web application, a progressive web application, to make itself available to the share overlay. And so what you need for that is a service worker, a web application manifest, and so to the point where it can be an installable progressive web app, work offline. And once you have that, you just add this to your web application manifest, part of the JSON, and you just call it a share target, give it a URL, an action, a path, and the parameters. That's actually just a way to map from the parameters that the Web Share API uses to your own parameters if you happen to use something different. And then your page just has to look into the URL and see if those parameters were passed to them, which is kind of nice. And I just wanted to show a demo quickly. I'm going to bring back, bringing back Android device here. If I click share it there, and I haven't managed to build one of these myself yet, but there is an example on from the Chrome team of a share target test. So this is a web application. It's a progressive web app. It's a glitch app, apparently, so it's gone to sleep. But it's back, so that actually kind of proves that it was a web application because it had to start glitch up. And there we have, like, this is the, I have now sent the my share things to this website via the share tray there. Apparently I'm not sending a proper URL, I'm just sending it all in the body. But that's fine, maybe I should fix that myself. Work to do. Cool. Let's go back to there. Support for that is less good. It's in Chrome. They did an origin trial and they suggested it was good, and now they're trying to get Safari on board. I think there's positive signs. There's also good signs that you might have seen so far that things you can share there are just text, but there is work going on to share files across things as well. Sharing files is pretty powerful, but also pretty dangerous, which is why they haven't got it yet. It's version 2 of the Share API, and it needs a little bit more careful handling. If you've ever tried to email somebody a JavaScript file, you'll know that Chrome is particularly, or not Chrome, but Google are particularly worried about that kind of thing. Should we be able to share a JavaScript file from, say, GitHub or something to somewhere else? Or would the other website not like that? Probably not. One other little thing, if you do want to implement the Web Share API, I wrote a web component for this. Web components are also out of origin trials, although amusingly enough, inside the origin trials, you can opt back in to the web components version 0 spec if that's what you did and you need to keep that going. Use the version 1. It's available in all the browsers now. But this web share wrapper allows you to wrap around a bunch of existing share links that you might have and replace them with something that supports the Web Share API instead. So it's a super simple way to start implementing this before, without removing all your existing work. So that's just an example. That's basically what's happening on my website that we saw the demos with there. I have some links for this. I will put all these slides online afterwards, so including all the links if you want to catch up on more of that. So let's get on to some more newer things. So those are available in browsers. Now we get into experimental web features and origin trials. And one of the first ones is it's a really interesting thing that the browser can't do right now, or only in experimental versions, is keep the screen awake. A lot of the time we expect, of course, our users to be using the application, scrolling, clicking, moving around. But if you are building more interactive things, things like if you want to do kind of running, lost my words, run tracking or exercise tracking applications where the phone just has to sit there and record stuff. If you have a game which has a more interesting kind of input, like using motion sensors and things like that, or if you have an interactive experience that allows people to, it's not a video, but people are watching and not interacting necessarily with something that's going on screen, then you want to keep that screen awake. And if you're presenting in front of a group of people, you also want it to keep awake as well. This is the point where it doesn't help me out here. This is the point where the presentation should actually be going to sleep on me. I was going to talk through until it did, but it's not going to. Doesn't matter. Oh, there it is. Ha! It's doing it. Oh, it's doing it on my thing. Anyway, it's gone really dark here. It's about to go to sleep. I'm going to wake it back up. It didn't do it on there. Okay. But what we have is the wake lock API. And sorry, I'm going to show you how it works. The wake lock API allows you to keep the screen or the system awake as a web application. Although right now, not the system one. If you ask for permission to keep the system awake, the wake API doesn't know what to do with that yet. There's still work to do on that one. Because that would imply that the screen can go to sleep, but a web application can continue working in the background. And that doesn't seem like something that would necessarily work yet. So they're still speccing that, but we can test with the screen wake lock. And so my demo was actually going to be making sure the screen never goes dark on me again for the rest of this thing. So I'm going to show you the code of how it works. So we get a wake lock object now off the window. And what you can do is just request screen. And that is where you'd request system as well. And that's it. It actually doesn't do a permissions request for this, which is probably a good thing. Keeping the screen awake is something you need to do for very specific things, but you probably don't need to interrupt your users for it. What's interesting about this is that it returns a promise. This promise is pending and continues to be pending. This is not a promise that is intended to ever actually resolve successfully. Its success is that it is currently in action, and that's a good thing. But this led me to discover a bit more about aborting requests. The wake lock API is something that we want to eventually turn off, but we can't. The browsers and JavaScript kind of developers went around a long time trying to work out a way that we could cancel promises. Cancelable promises was a thing for a while, but it failed ultimately. And the thing that actually took precedence was the abort controller. And so I don't know if you've seen this before, but it was actually kind of new and interesting to me. That if you want to intentionally abort a promise, then you need to use an abort controller like this. We'll create a new abort controller and then pass the signal as an option to the, in this case, wake lock request. And then later we can say, all right, we're done with that now. Abort that. That fires that effectively raises an exception within the abort controller's signal that had been passed to the request, and ultimately the promise will reject with an abort error as the reason. And so right here, if something has if the promise is rejected with an abort error, we're probably okay with that. Like, we probably intended that to happen, so it's actually fine. And this abort controller was not provided for the wake lock, but more for using in fetch requests and other kind of possibly long-running network actions or other actions like that. that you may want to cancel at some point. So if you didn't already know, and I don't think I quite realized it was happening like this, we can actually cancel HTTP requests in the web again. We don't have to fall back to XML HTTP request. So the week look is useful if you, as I said, if you have games, presentations, other things like that, and there are some links and demos right there. Next up is actually, I think, another really interesting one. Native applications for a long time have obviously had real straight access to the device that they're on and all of the data within that device. One of those data sources being the contacts. Now, this is quite private data. Again, this is why we're in an origin trial and why we're testing out this idea. Is this a good idea or not? Because contacts are are very personal to your user and their device. I don't know if you remember, it was a number of years ago now when Twitter got caught because installing the Twitter application pretty much resulted in you uploading your entire contact database to their servers. And like, well, that's not cool. I mean, like, I want to find my friends, but I really don't want you to know their phone numbers. And that's awkward. So we don't want to get into that situation if we bring this in for the web. So the contact picker API, it is supported if we have the contacts object on the navigator object in this case, and the contacts manager available to us. And once we have that, the contact picker API looks like this. We need to get control of our contact. And what we do is provide an array of properties that we want to get access to. Name, telephone number, email, and you can add addresses to this as well. And some options. So you can either have multiple, you can get lots of contacts, or just the one. In this case, this code is just going to ask for one. And then it is a navigator.contacts.select, using those props and options, will pop up a native contact picker. And even if you say multiple false, you're still going to get an array of contacts back. So in this case, returning the first contact is the answer. And a contact then ends up looking like this. It's just a simple object with the keys that you asked for, email, name, and telephone number. It has all the keys. If you didn't have any emails attached to that particular contact that you picked, then you'll have an empty array, and that's fine. Or you might end up with multiple phone numbers. These are not my phone numbers. Don't try and call me on these. It'll be somebody else. Address is a bit more complicated. There's a full-on address object that was actually implemented as part of the payment request API originally. And so contacts API just is sitting on top of that right now and saying it's just an address. It's fine. I wanted to show this as a demo. Yeah. This one I've got working in Android. Let's bring it up. Canary tabs. So cool. I end up, when I write demos, they tend to be fairly Twilio-centric. Hello. Oh, we got the wrong thing running. Bear with me 1 second. When I build demos, they tend to end up a little bit Twilio-centric. And so this is a phone dialer here. And what I've got is just 2 buttons. If this, you might have seen it in the load there, but there's originally just an input box for a telephone number. But because I have the contacts API, I can select a real contact. Some of these are not real contacts. I didn't want to put anybody's number on the screen. But I do wish I knew a person called Aardvark Johnson II. I'm just going to hide that away for a sec, whilst I actually select myself. There I am. Oops, let's actually select. Let's bring that back as well as QuickTime, because that's the good stuff. I've chosen my contact. It's selected my phone number, and now I should be able to actually call it. And this one will ring in just a sec. If the internet's with me. There we go. And I'm going to hang up on that as well. Cool. So I can just select my contact from my list. Aardvark, I wish. And call them. And I'm going to miss call on my thing as well. So that's Contacts API in action. I think that's really useful for, actually it goes quite hand in hand with things like the Share API as well, in which you might want to be choosing people to share stuff to, as well as anything where you want to put people in contact together. And so I like the fact that I can now, with entirely web technology, build an actual reasonable telephone inside my browser. Kind of cool. So this is the introduction to that online. It has a whole bunch of information about it, a whole bunch more, and there's a contact picker demo. This is the one that was written by the Google team. I will be publishing the demos I've written so far, but they all came in a little bit late, as you can imagine with demos. And the code is horrible. I don't want to submit you to that. I'm going to tidy that up, make it work. So next up, native file system API. I think this one's cool. And I'm first going to go back to here because I'm going to run the different server I'm supposed to use. Native file system API is great. We've had access to files in the browser actually for a while, but we got access via this. This big button with no file chosen, like that was our native file access right now. Or we could do drag and drop. Not a particularly useful thing on a mobile device if you're trying to get a file into an application. So we're kind of left with whatever this kind of file input did, whatever it looked like. It's impossible to style. You have to do horrible things to hide it and then pass events onto it. This was bad. But we could get access to files, and that was cool. But then, like, saving them, doing something with them, we're kind of left with a download attribute, an anchor with a download attribute, and then we just end up with a new file. And if we give it a blob or something, we can deal with that. But we end up with new stuff, and this has worked all right for us, but we can do better than that. And that is why the native file system API is now a thing. It's coming along. It actually has not a lot of API surface, which is kind of cool again. Calling on Windows choose file system entries function will pop open the file picker again. So we can now get rid of our input files and implement our own buttons and style them the way we want to, and just open a file system like this. But then once we get the file system, once choose file system entries responds, we get a file handle, which we can then use to get the file and open that up. And in this case, return the text inside. We can return it as text or an array buffer or a stream of data. There's one more, can't remember. In this case, text though, which is good. And then we can do stuff with it. And this is then, we can then do other stuff with getting file handles as well. In this particular case, if you pass the type of save file, that will create a new file handle for you, which you can then ultimately write to. That'll be a new file. We can also type as open directory, and that will give us directory access, so we can kind of traverse the file system via this stuff, and that's pretty exciting. But I have a demo for this one. It's actually in a tab over here somewhere. Not that one. Here we are. Cool. So this is not a very pretty demo, but this is the button to load the file. This is calling on that choose file entries API. And I'm going to go into, I'm actually going to open up the demo itself. So this is the code of it. And this is, I'm just running in the browser here, Monaco, which is the editor that actually is inside VS Code. They have made it available as a standalone package, so you can use it open source. And this is the code inside of it. It's actually not a lot of stuff here. Monaco itself is being loaded as an AMD module here, but all the code we have to use for getting the file picker is here. We got choose file system entries, get the file, get the text, put it in the editor. And then I've got a save button at the top there, which takes that existing file handle. So you want to keep hold of that file handle that you got for this file and creates a writer for it. And in this case, it's going to empty the file, then write it with all the text that's inside this editor, and then close the file handle. And that's it. So what I can do is, over here, like, the blink tag disappeared, didn't it? That'd be great if I could marquee though, that wouldn't it? Let's not do that. Let's just do a p strong. This was edited in the browser. And strong. And Monaco comes with all that lovely completion for you and things like that. And so if I just click save there, we get a permissions dialog. Again, this is a good thing. We need our users to know that we are now affecting their file system. And so this one tells me we'll be able to edit index.html in this case until we close the tab. So if I make that change, I've saved that now, but I could add something else. Save that again. It's not going to ask me this time. And in fact, if I come out of full screen a second, we should see that up in the top right here, just up here, it says that this page is allowed to edit files. So there's all sorts of ways that the browser is notifying the user that we still have access to the file system. This is a good thing. If I refresh that page now, it's not very obvious that I refreshed it. Oh, there it is. Yeah, I refresh the page, load that file up again. We can see both this was edited in the browser and something else, and the code is all there as well. So we just saved a file. We can now actually, what this means is we can build VS Code inside the browser. We never have to download an application again to write code. Is that what we want? Maybe. The native API, native file system API is going to give us access to that. So it is important to note that those permissions exist, though, and what doesn't quite work just yet, but will be coming in the future, will be a way to serialize the file handles that we get hold of and then store them in something like IndexedDB. So if we do refresh the tab accidentally, which I do all the time, or even close the browser accidentally, which I do absolutely all the time, we'll be able to reopen our session and continue to be able to save them without having to re-ask for permission because we can serialize those file things. That's coming soon. In the meantime, those are the links to check out for it. They actually, again, I will publish my demos eventually. That is a text editor demo that's actually not as cool as my one. So I'm quite... They tried to implement their own text editor. I was like, I will take Microsoft's VS Code work. Thank you very much. But I will tidy those up and share them. And then finally, the shape detection API. This is a really interesting one, and it's not necessarily something that we haven't been able to do in browsers before. Shape detection actually consists of using the camera or photo files or videos or the canvas to detect things within an image. So I remember playing around with getting kind of a JavaScript port of OpenCV to do facial detection in a browser. God, a number of years ago, I did a hackathon and I built an instrument that you played by moving your face around. It was terrible, of course, but it was a lot of fun. But it was slow, right? It was using an OpenCV implementation in JavaScript. What is much better is if you get access to the browser's ability to do that. And so the shape detection API gives us that access via 3 detectors: the face detector, a text detector, and also a barcode detector. So we can build into our applications things that detect faces, not facial recognition, but detection. We can build things that will detect any kind of barcode, from QR codes through to kind of product barcodes and things like that. So that's the kind of thing where you could build into your shop a way for people to check the price of an object that they're in a shop by just scanning its barcode and then telling them that you'll give it to them for cheaper, I guess. And finally, text detection. Text detection is really cool because, and I haven't got all of this working myself yet, so it's not my demo. But text detection is really cool because it can both detect where text is in an image, and if the capability is available to the browser, actually perform character recognition on that as well within the browser. So be able to give it an image of say, a restaurant menu or something, and then have it bring out all that text into real life. And then, of course, you could do translation on that. And then eventually you've built that kind of cool thing that Google Translate did, where you just take a camera up to a foreign word and then have it translate live over the thing. That's in the future. It doesn't necessarily work on all platforms right now. But face detection does, and that's what I was excited about. So I'm going to start up my camera here. Oh, that's my chest. And so actually, that's quite good, because right now we're detecting nothing. But if I bring my face in, I have a face, and that's all good news. Whilst we were testing with this yesterday, we worked out that if you don't have a mouth, you probably don't have a face. It's good to know. And actually, if I just open up the side here, what we can see is some of the data we get back. So you actually get data for the bounding box, so the top left for all the corners of the box. And you also get feature detection as well. So 2 eyes, nose, and a mouth. You will get array objects full of that data as well. So that's face detection API. And it works simply like that. And I can show you actually, let me show you the code for this one. It's probably this one. Yes, right. Move that away just quickly. Get excited about this stuff because here we go, literally inside a request animation loop, a request animation frame loop. This draw function here will detect a face, draw it on the canvas, draws the video onto the canvas, then for each face in it, and it does multiple faces at the same time, we'll draw that bounding box also onto the canvas, and it's working in real time. And if that's not good enough, the face detection thing can actually also be put into a web worker as well, and we can serialize the results across the post message API. So it will, if you are finding performance issues with something like this, we can do it, off of the main thread. And it's already working off the main thread, but if you really need it away, you can put it in a web worker as well. So there are some links on that. The shape detection API has a bunch of demos for it, which is good to see. Includes the text and the barcode scanning as well. So check out that. And that leaves me, that's the kind of 5 APIs I wanted to talk about today. As I'm excited that the web has a lot to offer us already. We can build incredible web applications right now, especially with kind of the advent of WebAssembly. And there's been a couple of talks about Blazor here, I think, today already, over the last couple of days. WebAssembly is going to allow us to do a lot more stuff, manipulating things inside the browser as well. Which means that these new powers that we can add to that, particularly things like face detection, these detection things, and file system APIs so we can put things back. I know somebody's built an entire video processor in WebAssembly that runs in a browser. But if you ever want to get the video back out again, using like a download attribute on an anchor tag is disappointing at best. So saving things and working with them properly is exciting. This ultimately will also lead to the ability for you to register a progressive web app to open a specific file type as well. And that will make applications on the web feel even better as well. So web has a lot to offer. We need to get it right though. And this is why these are all trials right now. This is why we are making sure the permissions work correctly. This is why the browsers are concerned about running too fast. So we need to get it right, which means the rest of us need to experiment with it. It's great that these origin trials and we can flip flags and put on experimental features. We need to experiment with these things too. And so I would love to, tell you to go out in the world, try some new things, tell me what you make with them. I'd love to hear because, and also tell the Chrome team as well. They need to hear this too. The origin trials come with that kind of implicit idea that you got to give feedback afterwards. You got to say, did this work for you or not? So write about it, publish those experiments, and let's all help to push the web on. That is all I've got time for you today. Thank you so much for joining me this morning, and come see me upstairs at the Twilio booth. Thank you. Guess we might have time for questions. If anybody has questions, come catch me afterwards. That's fine.